Hi friend, welcome back to Nick Pixel TV. Today I was doing bringing some equipment out to my property for getting ready to network between two buildings. And I thought I might make a quick video. Maybe it'll become a series of videos if you may find this helpful for your home, for your business, on how to get internet from building to building the right way, right? Or an easier way, or something that's gonna run better for you, okay? So imagine this. And hopefully there's not, too much glare on this, but you have two buildings, you have an internet connection, and you have maybe you have two internet connections, right? You might have Comcast, you might have Starlink as a backup. And you're typically going to see that come into a router, modem. Let's call it a modem. Some are modem routers nowadays. They're encompassed, but pretty much your provider is going to give you some type of a box. And when they give you that box, and hopefully this marker continues to work, they give you this box and they're going to say, do you want this run to your house? Do you want this run to your building? What do you want to run it to? So now you have your modem typically starting in like your house. Okay, so we say this comes over here and we have our internet connection to our house. That's all hardwired from the cable company. They bring the line in, they get to the house. And I'm going to try to make this video very simple to not confuse people. I'm not going to try to talk like a network guy. I'm going to try to talk like if you wanted to plug this stuff into your house and get it to work, right? So what I want you to think of is you have your internet connection and you have your two buildings. And these could be 500 feet apart, they could be 100 feet apart, they could be 2 feet apart. When you go between buildings, ideally you don't want to run like network cable, traditional copper cable between two buildings. You can get into grounding issues. There's several reasons why you wouldn't want to do that, but to do it right, you typically between buildings, and the cost has come down, you want to run fiber between two buildings. Lightning can't pass through glass. If this building gets struck and there's copper run between this one, you're not going to fry your other network switch. Ideally, you're just separating all these connections with glass, and lightning isn't going to transfer over grass. Lightning isn't going to transfer over glass. But basically, you're going to want to go fiber between the buildings. Now, there's also an option to go like point-to-point Wi-Fi between buildings. Now, there's different solutions for that if you don't have the ability to run a hard wire. But in this scenario, I feel like if you're looking for 100% solid service all the time and really reliability in your network, ideally you want to run fiber. And you can run this fiber in multiple ways. You can run it underground, you can run it overhead, you can have multiple pairs inside a single cable, you can have separate cables with individual pairs. There's several ways to do this. What I typically see done, and what we're going to do in my situation for right now we don't have the other building up, but I am going to start engineering this network so that I can have Wi-Fi across the property and more Wi-Fi across the property, and we won't have as much of a temporary home solution that most people just go to Best Buy and pick up. So when you're running these lines, let's just say you go building to building bridge. That's going to be, I'll show you that setup and I can show you how you can do that. That setup, you're still going to have some network components on each side, but you're basically going to have a dish on one side, a dish on the other, and those two dishes communicate, and then they come down to network equipment inside the building and network equipment inside the building. And the connection is air. Typically that's going to be line of sight and what you can see, say 1,500 feet or less. You can go way further, you can go miles, we can talk about all that kind of stuff, but I'm talking like traditional setups where you have a building a few hundred feet away. If you have the ability to run a trench and some conduit, then I would probably say go underground. Maybe some of you already have underground conduit that you can run through. The other thing is you don't have to worry about being next to electrical wires and things like that with glass and with the fiber versus with the copper. You don't want to run copper lines against power lines. So I think they're technically supposed to be like 6 or 8 inches away from each other or in separate conduits. So don't run Cat 6 cable between your buildings or Cat 5. Run fiber, and the price isn't that much difference. I mean, there is some, but it's a better way to do it. So we either run underground or we run this fiber overhead. What you're going to do is you're going to buy a fiber line with LC to LC connectors, and this is what that that looks like. There's little caps on these to protect the fibers, but this is an outdoor armored cable that can be run outdoors, it can be run underground, and basically this is pre-terminated, so you're ready to rock and roll. If you're gonna buy a cable like this happens to be 30 meters, so 100 and some feet, or around 100 feet. You can get this in 500 feet, you can get this in whatever length you want, and I can totally help you guys on this stuff, but this would be your fiber line. This is great to run even internally between switches. The chance of like lightning, if you run in between switches, let's just say you have a switch upstairs and a switch downstairs, and I'm going to explain switches in a second. If you have switches upstairs and a switch downstairs, and the upstairs switch gets hit with lightning first, or a power surge or whatever else, and that switch is connected with copper, you have a better chance of frying both of your devices, versus if you have glass between them, it may save it for you. It may save it for you. So I like to run glass between network switches. So let's talk about switches for a second. Most of you think of a switch as something like this. You see these little net gears around, they have the ports on them, and a lot of you, like hubs, they used to be called hubs back in the day, now they're switches, and there's a difference between a switch and a hub, but we're not going to go into that. Let's just say you have a switch. A lot of people think of them as like a surge protector or surge strip for like an extension cord. You want to get 5 more plugs on your extension cord. So you get one of these, you plug it in, you plug your one port into here, and now you can run more devices. And this is true. Some of these come as managed, meaning you can log into them and managed, and they get their own network address. Some of them come as just a dummy switch that you're really not going to manage or do anything. I tend to not use these because everything today is managed, and when you have bigger networks, you're going to want to be able to manage the individual ports and what they do. That's down the road. I'm just saying that if you're going to buy equipment right now, buy equipment that is going to not only do the job, but if a network person comes in to help you, you already have the equipment, and we can go through and just make some configuration changes. So a lot of you think of a switch like this. That right there is actually going to be this box here. A little bit more powerful switch. I do want to explain something else to you. Just for the fact of using numbers, that switch there, you're going to start seeing the term gigabit around. Gigabit internet, gigabit switches, gigabit routers, all this kind of stuff. Wi-Fi 6, Wi-Fi 5, 6, 7. You're going to see all these different terms. Let's just say that Wi-Fi networks, let's just shrink it down to a few years and just use numbers, right? You don't have to really worry about what it means, but typically in the last 10 years, you're going to see gigabit, which means 1,000. Before, network switches were 100, then they were 10, and so on and so on. A lot of the stuff is backwards compatible. So you'll see a gigabit switch, which means it can run at 10, it can run at 10-100, or it can run at 10, it can run at 100, it can run at 1,000. So if you're still seeing a switch in your network that says 10/100, get rid of that, because everything today is like the standard's gigabit. Now you're starting to see 2.5 gig devices where that's going to be 2,500, and then even 10 gig. So a connection like this fiber could run a 10 gig link between your buildings, providing you have the network equipment to do so, which would be 10,000. So if you're just thinking of speed, think of if something's going 100 and then you turn it up to 1,000 internal network speed. That's not your internet speed, but your internal network. You're gonna be good to go. So I try to buy things once, buy once, cry once. Whenever I do networks for people, whether it be at home or a business or an office or a combination of all those. So ideally, this is our switch for today. And this switch has a ton of capability. It's 24 ports. It's fully managed. It has power over Ethernet, so meaning we can send power to a device over the network. So instead of having to run a camera and have to run 110 volt power, you can take, let's just say, a security camera like this, and you can power it and it'll get network all with one cable. So all you have to run in your building, whether it be indoors or outdoors, is Cat 6 to everywhere that you need to run to. Ideally, you want to bring everything to a home base, and if you can avoid having all these little switches in between, you want to run everything, and they call that home runs, running from a switch out to a device, and no breaks in between. If that's the perfect best case scenario. Sometimes if you don't want to make another run, you can put a switch in between, but I would buy at least a managed one. Ubiquiti is what we're using for this network just because of the cost and the performance and everything else, it's a great solution. It's not the cheapest, not the most expensive. They make like 8-port switches that would be similar to that Netgear that I showed you, and you can use something like this. This isn't going to have the capability to do fiber. They do have some that'll do fiber, but you could use something like this in a jam if you need to. For this network, we're going to have, and this is kind of my portable rack setup that I have for if a business goes down and we need to run their network temporarily. I have a couple of these portable setups that can basically, we can engineer a network in minutes and have it ready to go. So I have a UPS power backup, which runs power. This is a 1U rack mount. These are made to go in racks, almost all this equipment. But it's a 1U rack mount. This one's made by Cyber Power, and this is my battery backup. So if the power goes out or power blips, all the network equipment stays up. My security cameras stay up. Everything stays up and going. Then we have, what we're going to use is a router, and that's in this box here. And then we have our switch. So when I talk building to building, I want to explain how this works. So we talked about our fiber line before we go into all this other network equipment. We talked about our fiber line. Let's just say right now, go out and get you a fiber line and run it between your buildings. You can get ones that have multiple pairs of these. Like I said, there's several options. Ideally, I like to get something that has, this only has 1 pair, but I usually like to get something that has 2 pair or 4 pair if I'm going to make that run, because I have a little bit of redundancy there and I can do some different things with networks. So if you have a big enough pipe running between buildings, or if you're going over the air, you may want to get one as a backup. Now, if they're running in the same pipe and somebody digs it up and breaks the cable, you're probably going to break all the fibers inside of it. So you could run a separate cable. There's several scenarios, but you can get by with just one. So we're going to run this wire between, let's just say hypothetically, we have a building 80 feet away. We're going to run this wire between them. Then what do, right? On this switch up here, and let's just say we have this switch on building A and another one of them in building B. You're going to take that connection and you're going to need these 2 transceiver modules. These happen to they usually come in a 2-pack. These are the 10 gig versions, so these can handle up to 10 gig. And this switch here on the right column here, this switch here also offers 10 gig. So if there's a 10 gig port on one side and on the other, those switches can communicate at 10,000, okay? For a lack of better terms. All you're gonna do is, these don't need programmed or anything like that. You're just gonna take these adapters, you're gonna pull out one of them, and I can show you how this works. You're gonna take this one out, pull the rubber cover off, and once you pull this cover off, basically, you're just going to connect that transceiver like that. And once that transceiver's on, you can just slide that, pull the cap off of this, slide that into this port, and do that on both sides. That's going to connect your switches between buildings. That's the easiest, probably safest, best way to do this, whether it be above ground or underground. Fiber cable, transceiver, plug it into the switches. There's several switches and switch models that will do this. Today we're using the USW Pro Max, which is a newer version from Ubiquiti, and that's going to be my switch that's in here. I also, in my network, have an aggregation switch, and then we need our router, and our router is going to go right below here. So today, I'm going to take a look and show you what we're going to use here at this. And my equipment changes all the time because I'm constantly testing stuff. This happens to be the Dream Machine Pro Max. What's nice about this unit is it hosts the software all in one interface. So your software for Protect, which is your camera system, if you want door access, they have an access system. They also have the network system. I think for this setup here, because I have a combination of cameras, I didn't want to have a separate NVR or things like that to get started. This will transition either way into different buildings. So this is going to be our controller and our router / firewall. And this box here, you could use at your home, you could use at your business. This would work really well for you. And it comes with a lot of cool features packed right into it. So right off the bat, I wanted to tell you, if we're gonna run we have a up to 2.5 gig Ethernet or internet port, so call that the wide area network, the WAN. You'll see things labeled as like WAN or LAN, local area network, wide area network. So think of Comcast being your WAN, and or Starlink being your WAN, and whatever you call your LAN could be your LAN, which would be local to you. So 10 gig on that side, and it also has hard drives because it has the NVR and the capability to have hard drives put right into this box to store your camera footage. Now, they make a model of this that only has one hard drive, so there's no redundancy. This at least has some redundancy. I didn't bring a drive out. I did steal this one out of another device that I have. So this is an 8 terabyte Western Digital drive, and I don't think they changed the, and they're labeled 1 and 2. That tray looks identical, so I don't think I'll have a problem there. But since this one's already cabled up, I'm going to take this tray out, and I'm going to put this hard drive in this unit so that we can have storage for our video cameras and our security cameras. I can add a second drive, and then they basically mirror each other, or I guess you could probably make them so that they just give you extra storage. You can choose extra storage or mirroring, but the idea would be to have this drive fails, you still have all your security data. But this is all built right in. So this could be our router, our firewall. It's going to control our network. And this would be like the first box that would be right against your cable modem or your Starlink modem or your Starlink connection or whatever connection you're using. This would be like the first in line. Then we're going to come out of this and we're going to go to the switch. So what's nice about this portable unit here is if I move all this stuff, I should be able to just slide this right in this rack, and then we will, all right, so we can slide this into the rack. That was a little bit cumbersome. So that's going to go into the rack. We can screw that down, and pretty much that's going to be our router for this network, and that's what's going to provide the capability to control our network. So now that that's in the rack, what I'm using here, and I don't like to do this all the time, but they are, I think, quicker, less latency, but I'm using what they call a DAC cable. Because these switches are so close, it's called a direct attach cable, direct attach copper cable. So basically, these two DAC cables connect all my switches here. Now you can buy fiber cables. I could also connect these, these two devices here and here with something like this, and they make short little patch cables that are glass, and that would protect you from connection in between, like copper connections in between each device. I do have those in the truck, so that could look something like this, okay? And you have LC to LC on each side. This is not armored cable, so this is, you can damage it a lot easier. But these two could connect as well. I'm just using the direct attach copper today, and that's what's plugging those two in. So there's an option there, and you can get those up to like 10, 15 feet, stuff like that. They're kind of made to be in a rack. So that's what these patch cables. Now just know that if you're going to use patch cables like this, you have to buy these adapters for each connection. A pair of adapters for each one of those connections. So the DAC cables are pretty inexpensive. I'm going to take this one DAC cable here, and I'm going to pull this cap out, and this is going to connect to our LAN side. So we have internet there, and that's port 9, that's 2.5 gig. I'm going to go probably just to this top one first. No, I'll go to the bottom one actually. No, it don't matter. I'll go to the top one. So I'm going to connect that up, and there we go. So these are just little loops that I have, and hopefully you can see that because I'm not zooming in, but we have a loop here. I am going to make a video on all this stuff close up when it's active. This was just high level of how you can connect a building to a building and get your network better at home, your business, whatever the case may be. So now that we have our router connected and our firewall connected, I do have a switch in between. It's my aggregation switch because I'm going to have other switches coming out of this. And then I have my main switch up here, and I have my power backup. On the back of this unit, I just have some jumper cables to go to the back so that when we're in a network, all the cables aren't coming across the front, they're plugged into the back. And that's the same as the power, and I'll show you that. Let me put this cable back. Also, they do make other devices besides stuff like this. They have a UniFi Gateway Max, Cloud Gateway Max that handles that stuff. A little bit smaller, going to be probably perfect for home. Has 2.5 gig ports. We could talk about that. They make like this UniFi Express. They make like next gen gateways you can host in the cloud. So there's several options. Don't think of this equipment as like what you have to do. This is probably overkill for many of you, but it's also nice to, you know, if you're not, if you have the budget to do it and you want a great setup that's going to last you 3 to 5 years or 7 years, or as long as the equipment lasts, probably more like a 5-year window. I'm turning stuff around a lot faster, but you plug this stuff in right here, it's gonna carry you. Let me show you the back of this. I do want to say you can also get Cat 6 outdoor. So if you are going to run Cat 6 outdoor to your cameras, maybe you have cameras on the outside of your house where the wire is exposed to ultraviolet rays, get yourself outdoor Cat 6 cable versus this blue indoor Cat 6 cable. Okay, so this is a spool of outdoor for what we need here. There's also Cat 6A. It really depends on the speed you're running. You'll get further distances on 10 gig, but for lack of better, most of your runs in your house are going to be 100 feet, give or take. Run Cat 6 or Cat 6A, and if it's outdoor or exposed to sun or ultraviolet, use the outdoor rated cable. If it's indoors, use the indoor rated cable. So on my portable network rack, this is the Ubiquiti Power Distribution Pro down here, and that comes off of my battery backup at the bottom. Everything will plug into this, and then I can control the plugs. If I want to reboot something, I can remotely power it on, power it off, stuff like that. So that would connect to the network, and then if I need to reboot something, I can just manually, like literally it's like pulling the plug. So I can control these plugs on the back of this, and like I said, this rack isn't made to be kind of set up like this. I set it up like this in a unique way that if we need to run into a business, throw this in as a temporary solution. We can wheel this thing in, we can plug into it. All the network cables come to the back and the power cables come to the back, and then everything in the front's wide open. So for me, I just have 2 jumper cables right now back to here. Out of this is where we're gonna run our devices, whether they be security cameras, and we have a couple different security cameras here. This is the UniFi AI Professional. We have a couple different types of cameras. We have access points. These are access points that you could use in your house. You can run these off your network, and you can control everything. We can even set up VLANs to separate your network so your cameras stay on one box and one container and all that kind of stuff. But you're going to see a lot of these like dish looking that mount on the ceiling, and you want to think of Wi-Fi when you're doing a building is just like cellular service. They put the towers up high and it broadcasts out. If you mount these up on a ceiling too, it's the same thing. So you don't really want them like down facing up or sideways or whatever else because of the radiation patterns of the Wi-Fi. But we also have an outdoor unit. This is going to be probably our outdoor unit here. It's a U7 outdoor. This is going to be a really good unit for, you can beam this in a direction for actual Wi-Fi, or you can use the Omni antennas and you'll have a little bit more around coverage. But this is going to cover a good bit of ground outdoors. So we're going to be setting this kind of stuff up. But this is like one system that'll kind of do it all. The goal today is really to get rid of, I just have, like you, I bought like a $300 Netgear router that actually was made for my camper for when I was on the go, if I wanted to set up my own network on the go. And then I kind of got into more of the portable stuff. You know, that's what we're going to set up here. And this unit, since we may need to move it, is just going to be like temporary. I'm going to bring my connection into here. We're going to bring the internet connection into here. I'm going to get that all set up, and then we'll do another video. If you think that any of this would be helpful to you, or if you are trying to do a certain setup, shoot a little comment down below, and I'll see if I can help you out. And then you can also visit Nick Pixel TV if you want like some network consulting or whatever the case may be. I'd be more than happy to help out or take a look at your project. But this is what we're going to start here with at the Gridside property, and it's going to evolve. We have a lot more equipment. I have a lot more stuff to unload, but ideally we want to get this building covered. As we redo this building, we want to have our new building covered. We want to have the camper covered and the toy hauler, like just the whole area. for people to come and enjoy. So that's going to be our setup. Today I'm going to get everything configured, and then we'll do another video on talking about specifics and what we pulled out, and you'll be able to see some of this stuff in action. But if you're going building to building, run fiber, order some fiber connections. We'll put a switch on each side, and you're going to be good. If you want to talk point to point, I'll do a video on that too. We can do some tests here at the property. Sorry for all the road noise. I just wanted to set up. I thought unloading some of this stuff, I could just talk about a few things and what we're getting ready to do here. And we have to bring a 200 amp service to this building. We have a 200 amp panel for an outdoor 200 amp panel, and then we'll have our panel for the building. So it's between electrical and network, all this stuff goes together. If you're going to do it, if you're building something new and engineering it, you might as well just plan for this kind of stuff. This way, long term, you can mix and match and move things and do things, and everything's going to work. Hopefully this video is helpful. I will see you in the next Pixel, and maybe YouTube will share a little video that you can watch next. Take care.